So, a pleasant day to everyone. Today, we will be diving into one of the most fascinating and dynamic part of the Earth's atmosphere, the weather systems and phenomena. Throughout today's discussion, we'll be exploring key topics that are crucial to understanding how our weather works. So we hope you are as excited as we are to delve into this incredible weather phenomena. Let's get started!
Good day everyone, I'm Mimikos Miguray, a student of BSED Science 2, and today I'm going to discuss about air masses and fronts. Did you ever stop to think about what creates the weather patterns that we see every day? It's all due to fronts and air masses. In this lesson, we will discuss what fronts and air masses are and how they create the weather patterns that we see. We will also talk about the different types of fronts and how they can affect the weather. So, if you're curious about what makes the weather turn windy or sunny, keep tuned. We all know that weather is influenced by factors like humidity and temperature, and that global patterns of circulation and heat transfer cause huge amount of air to move around the planet. Now, let's put this all together to talk about how these changes really happen through air masses. Air masses is a large bodies of air with similar temperature and humidity throughout. They can thousands of miles across and several miles deep, and they're moved around Earth's surface by global wind patterns. Air masses also tend to have consistent air pressure. The force air exerts on Earth's surface as it pulled down by gravity. Air pressure is also directly connected to temperature. The area over which an air mass originates is what provides its characteristic. The longer it stays over its source region, the more likely it will acquire the properties of the surface below. But how do air masses form? Air masses form when a large volume of air remains stagnant over a region with consistent surface conditions like vast ocean or large desert. This allows the air to take on the temperature and moisture properties of that surface. Air masses are classified based on their source region, but now let's talk about the latitude. Arctic air masses represent with the uppercase letter A originate over the Arctic or Antarctic regions and therefore are very cold. Polar air masses represent with the uppercase letter P originate over the higher latitudes of both land and sea and therefore not as cold as Arctic air masses. Tropical air masses represent with the uppercase letter T originate over the tropical region and therefore are warm and hot. Equatorial air masses represent with the uppercase letter E formed around equator and they carry very warm air. Now, let's move on to the surface. We can also specify whether the air mass is maritime, meaning it formed over ocean, or continental, meaning it formed over land. How do you think forming over land or water would change characteristic of an air mass and the weather it brings? Maritime tend to be more humid, while continental tend to be more dry. So, if we combine that, a continental Arctic would be extreme cold and dry because it originates in Arctic region. A maritime polar would be cold but moist due to its origin over oceans. Continental polar would be cold and dry because it formed over large areas in high latitude. Continental tropical would be hot and very dry because it formed in tropical region. And maritime tropical would be warm and moist since it forms over tropical ocean waters. What happens when two air masses meet? The boundary between air masses is what we call front. Front is a transition zone or boundary between two air masses with different temperature and humidity characteristics. Fronts are dynamic and are associated with significant weather changes. But how do fronts form? Fronts develop at the boundaries between air masses when they interact. The movement and collision of these air masses create the frontal zones. Fronts are classified primarily by the movement of the air masses involved. This means you look at which air mass is advancing and which is retreating. So here's now the breakdown of the four main types. Cold front is when the cold air mass moves into an area where warmer air mass has been. It represents the symbol of blue line with triangles pointing in the direction of movement. Cold air sinks under the warm air, having the warm area to rise rapidly and cool, which can lead to the formation of towering cumulonimbus clouds and thunderstorms. Cold fronts often bring short but intense storms, and the weather after the cold front passes tends to be cooler. It's like a bulldozer pushing warm air out the way. Warm front is when the warm air mass moves into an area where the cooler air mass has been. It represents with the symbol of red line with semicircles pointing in the direction of movement. So as the warm air mass rises over the cooler air, it often cools and condenses into stratus clouds, leading to long period of light rain. Then, the weather after the warm front passes tends to be warmer and more humid. It's like a warm blanket slowly spreading over a cold surface. Stationary front is when two different air masses meet, but neither strong enough to move on the other space. It represents with a symbol of alternating blue triangles and red semicircles. Stationary front doesn't create a warm or cooler front. It's like a tug of war where neither side is winning. Lastly, occluded front. It occurs between the place where warm front and cold front meet. Basically, they happen when the warm air mass is moving between the two cold air masses. It represents the symbol of purple line with alternating triangles and semicircles on the same side. Understanding fronts and air masses are important for understanding weather patterns because they help to explain why certain weather conditions occur. For example, if a cold front moves into an area of warm, moist air, then the result will be heavy precipitation. Conversely, if a warm front moves into an area of cold air, then the result will be mild weather. Air masses and fronts are also important for predicting long-term weather patterns. By understanding these concepts, you can better predict the weather in your area. Stay safe during severe weather by being prepared.
Hello everyone, this is Elsie Irene Dominic Ayanan from BSED Science 2, and today we're going to take an in-depth look at weather patterns, cyclones, and anticyclones. Some of the most fascinating and impactful forces in our atmosphere. Throughout this video, we'll explore how these weather systems form, what makes them unique, and how they affect our daily weather. So let's get started. Let's kick off with weather patterns. Weather patterns occur when weather conditions remain consistent for several days or weeks. We've all experienced weather patterns like hot and dry spells, wet and rainy days, or stretches of cold weather. While they may seem harmless, if these patterns continue for too long, they can lead to serious emergencies such as heat waves, flooding, and blizzards. Have you ever experienced an extended weather pattern? Maybe a heat wave or heavy rains that lasted for days. These patterns aren't just random. They're actually driven by a variety of factors. Temperature, humidity, atmospheric pressure, precipitation, and wind all interact in a complex way to shape these patterns. For instance, high pressure usually brings clear skies while low pressure can lead to unsettled weather like storms. Meteorologists study these patterns to predict future conditions and identify long-term climate trends. Now, let's talk about one of the most dramatic weather phenomena: cyclones. The word cyclone actually comes from the Greek word kyklos, meaning circle. And that's a great way to picture it. Cyclones are large-scale air masses rotating around strong low-pressure center, with winds spiraling inward. And in the northern hemisphere, they spin counterclockwise, and in the southern hemisphere, they spin clockwise. Can anyone guess what conditions cyclones need to form? Let's break it down. Cyclones form when warm, moist air rises, creating a low-pressure area at the surface. This rising air cools and condenses, releasing heat, which then fuels the cyclone. Cyclones need warm ocean temperatures of at least 26.5 degrees Celsius or 80 degrees Fahrenheit and a low-pressure system to get it started. There are several types of cyclones, each with its own characteristics. First, let's start with tropical cyclones. These include hurricanes and typhoons. They form over warm ocean waters and are known for their distinct eye wall, and rain bands. They're fueled by heat released from water vapor condensation. Next, extratropical cyclones. These occur in mid-latitude regions, forming along fronts where cold and warm air masses meet. They can bring diverse weather, from thunderstorms to snowstorms. And lastly, the subtropical cyclones. These type of cyclones share features of both tropical and extratropical cyclones. They form in the northern Atlantic and eastern Pacific Oceans and have winds ranging from 39 meters per hour to 74 meters per hour. Cyclones are among the most powerful forces of nature, often causing widespread destruction. But did you know there's an opposite system? Let's take a look at anticyclones. An anticyclone is the opposite of a cyclone. It is a high-pressure system with winds spiraling outwards. In the northern hemisphere, they rotate clockwise, while in the southern hemisphere, they rotate counterclockwise. Unlike cyclones, anticyclones bring stable weather such as clear skies and calm conditions. So did you guys ever wonder why we got such nice sunny day in the middle of the summer or crisp clear mornings in the winter? That is because of the anticyclones. So how do anticyclones form? Anticyclones form when air sinks from high altitude, compresses, and warms up. This leads to clear skies and stable conditions. However, if anticyclones stick around for too long, they can cause droughts and heat waves in the summer or frost in the winter. Now, let's discuss the three special types of anticyclones: the polar highs, the mid-latitude anticyclone, and the subtropical highs, also known as the horse latitude. So polar highs are the high-pressure system found near the poles caused by cold, dense air sinking. Polar highs typically bring clear, cold weather and are most prominent during the winter. Up next is the mid-latitude anticyclones. Found between 30 degrees and 60 degrees latitude, this high-pressure system brings dry and settled weather. They play a key role in influencing the weather in regions like North America and Europe, often blocking storm systems. And lastly, the subtropical highs, or the horse latitude. Located around 30 degrees latitude, these zones are known for their light winds and dry, stable conditions. Historically, sailors dreaded these calm areas where the ships could get stranded, hence the name horse latitude. These highs are responsible for creating some of the world's deserts, such as Sahara and the American Southwest. So to wrap this lesson up, we've seen how weather patterns, cyclones, and anticyclones are vital components of our global weather systems. These cyclones bring intense and sometimes destructive storms, while anticyclones bring calm and stable conditions. Both systems shape the weather we experience every day, from storms to sunny skies. So that's it for this lesson. Thank you for tuning in. And now, to continue our journey into the world of atmospheric phenomena, I'll hand it over to Mr. Jerry James Pugoy, who will be discussing the next topic. Stay tuned!
Good day everyone, I am Jerry James Galvadores Pugoy and I'll be your next reporter. So our topic for today is all about extreme weather events, hurricane, tornado, and thunderstorm. Okay, let's start. Hurricane. What is exactly a hurricane? A hurricane are one of nature's most powerful storms. They produce strong winds, storm surge flooding, and heavy rainfall that can lead to inland flooding, tornadoes, and rip currents. Known generically as tropical cyclones, are low-pressure systems with organized thunderstorm activity that form over tropical or subtropical waters. They gain their energy from warm ocean waters. As storm systems strengthen into hurricanes, the surface winds move continuously in a circular motion. Meteorologists refer to this pattern as closed circulation. The direction of circulation is different depending on where the storm is located. It is counterclockwise in the northern hemisphere and clockwise in the southern hemisphere. These rotating winds lead to the development of the characteristic eye of the hurricane, the calm, clear center of the storm. The eye is surrounded by the eye wall, where winds are strongest. Tropical cyclones are classified by their maximum wind speed. As you can see here in the first picture, it shows that this is the initial stage of a tropical cyclone with a defined circulation and sustained winds of 38 miles per hour or less. It's like a fledgling storm showing potential for growth. Next picture is when a tropical depression strengthens and its wind reaches to 39 to 73 miles per hour, it becomes a tropical storm and is a given name. This is more organized storm with stronger winds and heavier rainfall. So this picture is known as tropical storm. And lastly, this picture is the most intense stage. A hurricane has sustained winds of 74 miles per hour or higher, featuring a distinct eye and powerful winds that can cause significant damage. These storms are capable of widespread destruction due to high winds, storm surge, and flooding. So this picture is called a hurricane. Fun fact! Hurricanes, typhoons, and cyclones are actually all the same type of storm, but have different names based on where they form. In the North Atlantic and Central and Eastern North Pacific, these storms are called hurricanes. In the Western North Pacific, they are called typhoons. And in the South Pacific and Indian Ocean, they are called cyclones. Tropical cyclones are rare in the South Atlantic. I'll offer some tips on how to get ready for the upcoming hurricane. Water, not wind, is the biggest threat. Though hurricanes are well known for strong and destructive winds, hurricane storm surge is the greatest threat. Run from the water, hide from the wind. When you're at risk from flooding, it's important to get high ground away from bodies of water and any flood-prone areas. When there are high winds but no danger of flooding, rare in hurricanes but also important during any storm, it's important to shelter in a sturdy structure, away from doors and windows. This is why most evacuation orders are given for water, not wind. Stay safe after a storm passes. Hurricane-related hazards don't disappear when the weather clears. After the storm, use generators safely. Be careful not to overexert yourself. And do not venture into storm-damaged areas before it is safe to do so. And that's it for hurricane, and now let's move on to tornadoes. Tornadoes. Tornadoes are vertical funnels of rapidly spinning air with winds that can reach to 250 miles per hour, clearing paths up to a mile wide and 50 miles long. They are most often born in thunderstorms, especially destructive supercells, and are common in the US, particularly in Tornado Alley, which includes states like South Dakota, Kansas, and Oklahoma. Tornadoes cause significant destruction, damaging homes, business, and infrastructure. The majority of tornado-related deaths and injury come from flying debris, but forecasting improvements have reduced fatalities over the years. Thunderstorm. A violent short-lived weather disturbance that is always associated with lightning, thunder, dense clouds, heavy rain or hail, and strong gusty winds. Thunderstorms arise when layers of warm, moist air rise in a large, swift updraft to colder regions of the atmosphere. Thunderstorms are known to occur in almost every region of the world, though they are rare in polar regions and infrequent at latitudes higher than 50 degrees north and 50 degrees south. The temperate and tropical regions of the world, therefore, are the most prone to thunderstorms. Here are some fun facts about thunderstorms. Thunderstorms may occur singularly, in cluster, or in lines. Thunderstorms are classified severe if they produce hail at least 3/4 of an inch in diameter, have winds of at least 58 miles per hour or higher, or if they produce a tornado. All thunderstorms contain lightning. The rapid heating and cooling of air near the lightning causes thunder. Thunderstorms are dangerous storms with lightning. A lightning strike can kill you. Here are some safety tips for preparing a thunderstorm. What should you do before a thunderstorm? Identify a sturdy building and practice drills. You need to get inside a sturdy building before a thunderstorm hits. A sturdy building is a structure with walls and a foundation. Once you have identified a sturdy building, plan to shelter in the basement or a small interior windowless room on the lowest level to provide additional protection from high winds. Plan to stay inside until weather forecasts indicate it is safe to leave. Plan to stay connected. Sign up for free emergency alerts from your local government. Plan to monitor local weather and news. Have a backup battery or way to charge your cell phone. In case of a power outage, have a battery-powered radio. Understand the types of alerts that you may receive and have a plan to respond. A watch means to be prepared. A warning means to take action. Learn emergency skill. Learn first aid and CPR. Utilities may be offline. Be prepared to live without power, gas, and water. Plan for electrical needs, including cell phones and medical equipment. And that concludes my report. Thank you for watching and listening. Bye!
And that brings us to the end of today's discussion on weather systems and phenomena. We've covered a lot of ground, starting with how air masses and fronts, as explained by Ms. Noemi Garay, set the stage for the weather patterns we experience every day. We then explored weather patterns, cycles, cyclones and anticyclones in my presentation and saw how the systems interact to create everything from calm sunny days to powerful rotating storms. And finally, Mr. Jerry James Bogoy took us through some of the most dramatic forces of nature, hurricane, tornadoes, and thunderstorms, and explained how these extreme conditions develop. And by understanding these weather systems, we not only gain insight into how the world around us work, but we also learn how to better prepare for the future. Whether it's predicting tomorrow's forecast or responding to severe weather conditions. So everyone, thank you for joining us in this journey through the world of weather. We hope you found it insightful and engaging. Stay safe, stay curious, and keep learning. Have a great day.